Hello, everyone. We're the Delta team, and we're building a pre-boarding recommendation system for passengers. The team is consist of 4 people: Cynthia, Effie, Matthew, and Mikli Liu, which is me. And we will do the overview, and this agenda consists 4 parts: executive summary, new business application, data warehouse and ETL design, and also potential opportunities. We'll move forward to the Delta part. Delta Airline is one of the world's leading global airlines, operating at an immense scale with a vast network of international domestic routes. Delta connects millions of passengers to destinations around the globe. What truly sets Delta apart is its commitment to excellence. The airline is deeply customer-centric, consistently delivering exceptional service and fostering loyalty among passengers. Delta is also a pioneer in technology leadership. For example, it introduced the first ever biometric terminal in the US, allowing passengers to check in, pass through securities, and board their flights with just a facial scan. This innovation highlights Delta's ability to seamlessly integrate cutting-edge technology into travel expense. Then we'll move on to their existing database. The RDBMS. The database schema is designed to have 7 large categories in total of 25 tables, which we believe is crucial to consider that can conclude most of Delta's operational needs. This covers various aspects such as flight operations, passenger and customer data, ticketing and sales, crew and staff data, aircraft maintenance, financial data, and human resources. At the time when we were designing this data storing system, the following key items must be put into considerations. What legacy data is already in the system and transferred from paper document to RDBMS? And how do we store future data concerning the demands in the speed of making decisions as well as technology advancement? Storing data that is collected in unstructured forms, such as real-time flight data, will be very challenging for RDBMS. Therefore, considering NoSQL database might help. The NoSQL database consists of 2 types, DynamoDB and MongoDB. DynamoDB consists as efficient to store small size of data inflow due to its low latency key value access, which is shown on the upper right. The data file is look like that. MongoDB is suited for storing information of customer interactions, operating logs, social media metrics, and environmental data, as it can handle complex nested documents, which is on the lower right. We have also implemented LLM-generated unstructured data to mimic real-time data flows into the system and stress test the capability of these 2 storing systems. For implementing DynamoDB, we could expect this can handle small size of the data flowing in at a given time. However, as the scale of business goes large, we could consider using Spark streaming to handle large size data flowing in, as decision-making is time sensitive. The last part is the reason we consider using Hive is to utilize its capability of storing large size files like historical archives and allow simple queries to storing and updating data in HDFS. For NoSQL data warehouse design, Hive is our top pick because Hive SQL is simply like MySQL, which would not require learning a new language data if we were using Pig. For firms who are already managing RDBMS, it will be relatively easier for them to move to Hive. Now I'll pass on to Cynthia and do the second part.
So our new business application is enhance data's passengers experience with a personal recommendation system. Passengers often face uncertainty during pre-boarding, such as long waiting time, travel location service, or choosing dining options. Our solution leverages AI and location-based features to deliver real-time updates and targeted guidance. This reduced stress, improved operation efficiency, and strengthened Delta broad loyalty, especially among high-value travelers. So key benefits include an enhanced customer experience, smoother operations, increasing revenue, and a stronger relationship with frequency flyers. And our system is powered by an enhanced database built by Delta existing data, include like the flight, store the flight details, and the customer capture the passengers' profiles. We also add the tables like check-in checkpoints and security checkpoints to track the waiting times, and the passenger's preference to store dining and shopping preference. This structure enhances seamless data flows from the check-in into onboarding and ability to accurate and personalized recommendations. And here's how it works. We start by assessing a passenger's real-time state. For example, if not check-in, they will receive content location and waiting times. After security, personalized recommendations are generated based on their preferences, like dictionary needs and proximity to their gate. And our score system using 70% proximity and 30% rating to rank options. The result, the passengers enjoy the stress-free journey, and the Delta benefits from reducing bottleneck and increasing efficiency. Finally, let me guide you through our deep diamond. The user start at the login page and then moved on the profile recommendation and the dashboards. So here we start. Let's see how it works. Welcome to Delta Airlines Thematic Airport Experience Guides, an innovative tool designed to enhance your airport journey. First of all, you need to enter your right customer ID If you put the wrong one, it will say the invalid. For example, my customer ID is wrong, that is login. And then you will see the home page. It's a link to 4 key features: the home, the profile, recommendations, and you can also view the dashboard as well. If you click the home page, it will jump to the data website, which you can see all the information you need. And then if you click the profile page, you can see all your personal details, ensuring a smooth clicking process. And then if you click the view your dashboard detail, you can see all the information about your flight's detail and something about your preference. You can edit your preference in this one. If you choose all your preference, then go to the See preference. And the final page is one of the most important one, is our personalized recommendation page. This can use for your preference and flight detail to suggest your dining options, which is the most near to your gate. It shows the distance about your gate, and it can also show the rates and the restaurant name of it. You can choose if you like it or not. This can help you to make the most of your wasting time. What's more, if you didn't book the flights, it will give back your information if you didn't book the flights. And then if you didn't pass in the security or you didn't check in, then it will show you should check in and tell you the current wait time of it. So with this guide, Delta can refine the convenience and customer satisfactions. Experience the future of travel with us. So here's the demo of it, and let us move to the next page.
Thanks, Cynthia. Moving on to our data warehouse design and ETL process. So the main objectives of our star schema are creating the star schema are enabling Delta to give data-driven decisions on customer personalization and operational optimization. And our key trends here include the frequent flyer analysis, preference trends, in this case mostly food and drinks because it's related to our recommendation system, and also hub-based targeting. So taking a look at our star schema diagram, we can see the fact table in the middle called customer flights fact table. The grain of this fact table, meaning each record represents a customer flight event. And our fact table is linked to 3 DIM tables using foreign IDs, customer ID, foreign keys called customer ID, flight ID, and preference ID. Our DIM tables, flights DIM stores flight-specific information. Preferences DIM has combines food preference, drink preference, and shopping interest of customers under one ID called preference ID. And our customers DIM table stores the full name and the frequent flyer status of our customers under Delta, such as bronze, silver, gold, diamond, etc. So how we populate these star schema, we use the ETL process. We extract data from operational databases that we created in part 2, such as customers and flights, as Cynthia just talked about. And then we transform this data, we clean this data, and then we populate and we load the data into our star schema tables in Delta DWH database in MySQL. Just a few decision-making queries that highlights how this star schema, how this fact table can be used. These are just a few examples that we created. I just want to highlight 2 of them. First one is the top destinations by frequent flyers. So here, this graph, this stacked bar chart shows the popular destinations for each tier of Delta customers, meaning if we look at Atlanta, which customers fly here the most in terms of status, such as bronze, diamond, silver, gold. So this way, Delta can customize their promotions and target certain type of customers while they're giving out promotions, which could help them be more efficient in their promotions. Also, another one could be food and drink preferences by origin. By looking at this heat map, Delta can effectively change their in-flight services by offering certain types of food and drinks in certain origins. And by this will help them achieve efficiency, this will help them make more revenue, and this will also help them achieve customer satisfaction, which is really important in Delta's business model. So moving on, why do we even have the fact table and these queries? Because we want to add business value and we want to have actual insights for Delta. What actual insights do these star schema add? It adds personalized promotions using the destination insights. Delta can target frequent flyers. It helps Delta optimize their services. As I just mentioned, they can adjust food and drink offerings based on their origin and their customers' preferences. They can also enhance loyalty programs to focus on frequent flyers distribution based on the hub. And what value does this add into Delta's business? It will help them increase their revenue. It will help them enhance their customer satisfaction, which is really important. And it will also help them strengthen their loyalty programs through data-informed decisions. So this data warehouse also has a few possible challenges. First one is maintaining data consistency across sources. As we just walked through part 2 and part 3, we get our data from various sources, so we have to make sure there's consistency. And also the ETL process should be more automated, because this was kind of like a batch size ETL process, which is not automatic, which could be done in parts, and this could be an issue with the scaling. But obviously the Delta could address it with some implications in the ETL process. Now I'm gonna leave it to Matthew to talk about some potential opportunities.
Thank you, Fa. Looking as well into some innovation and challenges, some of the first things we have to look at are enhancing customer experiences, where we want to further personalize recommendations. Say, for example, if it's an early morning flight, we want to suggest coffee shops. If it's for international travelers, we want to look at duty-free stores instead. We also want to look at operational efficiency through geospatial data, such that we want to leverage real-time geospatial data in order to optimize passenger flow and reduce congestion at check-in counters as well as security checkpoints. And that way, we also want to have future integration of an interactive airport map, where within Delta's mobile app, customers can efficiently navigate through terminals. We're also looking at increased revenue streams, such that we want to improve partnerships with airport vendors by directing passengers to retail and dining establishments, potentially increasing revenue for Delta and its partners, with calculations of, say, up to 72 million annually. We also want to look at scalability and future integration. We want to look at, say, Hartsfield-Jackson Atlanta International Airport, because our original data set looked at one airport only. And so Delta can refine the system from there before expanding to other major hubs. There's also a potential integration with Delta SkyMiles loyalty program to deliver exclusive offers, such as bonus miles for spending at partnered vendors or dining establishments. Some of the challenges we encountered during the developmental process were data generation and synthetic validation. Because we lacked real-world data sets, even among competitors where we tried to find similar data sets, we couldn't. So we ended up requiring a generation of synthetic data instead to ensure a relatively realistic and representative data. The schema design for complex relationships also had to handle diverse and interconnected data sets while maintaining normalization and query efficiency. We also had to perform transformations for star schemas, such that we needed to optimize the dimension and fact tables for the data warehouse, as well as requiring a significant effort to clean and normalize that for OLAP readiness. Finally, we have to handle the time and distance, such that the check-in and security wait times are rather predetermined over historical TSA data, such that we assume that this information has already been calculated from existing systems. There's also challenges which include ensuring accurate representation of distance, where we currently use the Euclidean distance rather than look at an actual map of the airport itself. That sums up our presentation. Thank you. If you have any questions, please let us know.
50 minutes.